The oldest light in the universe is pointing straight at us, and not in some vague cosmic neighborhood sort of way. It lines up with the exact plane that our own planet traces as it circles the sun. Imagine something reaching across the entire sky, drawing one enormous arrow and setting the tip right on top of you. For 500 years, the most reliable idea in all of science has said that we sit nowhere important. Yet the afterglow of creation itself now seems to stare straight back down our home address. Either the map of the cosmos is broken, or we are, and it is very much worth working out which. To see why this counts as a genuine emergency and not just a spooky coincidence, we have to rewind to the idea it threatens. So let's head back to cosmology basics. In 1543, a Polish astronomer named Nicholas Copernicus published a book arguing that Earth sits at the center of nothing at all. Our planet goes around the sun, not the reverse. And back then, saying that out loud could end a career. It also turned out to be the first domino in the longest winning streak in the history of human thought. The sun, we later learned, holds no special spot either, sitting 2/3 of the way out on one spiral arm of the Milky Way. The Milky Way claims no center of its own, standing as one galaxy among roughly 2 trillion. Every single time we have bet that our location is special, the universe has quietly informed us that it is not. We call this the Copernican principle, the plain idea that on the largest scales there is nothing unusual about where we sit or which way we look. This is not just a tidy philosophy, because the assumption gets baked straight into the equations. When cosmologists write down the standard model of the universe, the one we call Lambda CDM, they assume from the very first line that the cosmos looks the same in every direction, homogeneous and isotropic. Get that assumption wrong, and the math does not bend a little, it breaks all the way down. So we went hunting for a way to test it, and we found something close to the perfect ruler. Around 380,000 years after the Big Bang, the universe finally cooled enough to let light travel freely for the first time. That ancient flash still reaches us today, stretched by billions of years of expansion into a faint hiss of microwaves arriving from every direction at once. We call it the cosmic microwave background, the afterglow of creation, and it holds the same temperature everywhere, about 2.7 degrees above absolute zero, steady to within 1 part in 100,000. That map is almost perfectly smooth, and the word almost is where this whole story lives. Tiny temperature ripples run through it, and those ripples are the fossil record of the infant universe. To study them, we break the entire sky map into patterns of different sizes, a bit like separating a musical chord back into its individual notes. The broadest, biggest patterns get names, so the 2-lobed pattern becomes the quadrupole, and the next one up becomes the octopole. In a random Copernican universe, these giant patterns should sprawl every which way, pointing in completely unrelated directions, because the newborn cosmos has no reason to favor any axis. When we finally measured them, they refuse to point in random directions. In 2004, a team led by Angelica de Oliveira Costa spotted something that had no business being there. The quadrupole and the octopole, 2 vast and supposedly independent patterns stamped onto the sky at the dawn of time, were not merely both unusually flat, they were lined up with each other. A year later, Kate Land and João Magajo at Imperial College London ran the numbers, published a paper, and handed the thing a name, calling it, with a wink toward a famous political speech of the era, the axis of evil. Here is what they turned up. The alignment does not stop at the quadrupole and octopole. It carries on through the larger patterns, and taken together it rules out a purely random universe with a probability above 99.9%. The axis aims roughly toward the constellation Virgo, and it sits remarkably close to the ecliptic, meaning the flat plane that our solar system's planets orbit within. Sit with how strange that arrangement really is. The cosmic microwave background was printed onto the sky more than 13 billion years before the sun existed, long before Earth existed, and long before there was any ecliptic for anything to line up with. That light had no way of knowing which direction our little planetary system would eventually choose to spin. Somehow, the pattern in the oldest light we can see appears to care about the orientation of the youngest structure in the whole story. The physicist Lawrence Krauss laid out the options bluntly. Either all of science is wrong, and we truly sit at the center of the universe, or the data carries some contamination, or something is deeply broken in how we picture the cosmos on its grandest scales. Naturally, everyone reached for the second option first. There is no quieter kind of desperation in science than a team praying that their billion-dollar satellite is defective. The axis first showed up in data from NASA's WMAP satellite, and for years the comfortable story blamed a calibration quirk inside that one machine. So we built a better instrument, the European Planck satellite, a completely separate design running about 10 times more sensitive. It mapped the very same sky through the 2000s and 10s, and the axis of evil was still sitting right there. Before we go join our crazy uncle over in the anti-Copernican Facebook group, a few honest cautions belong here. We only ever get one sky to measure, and it holds just a handful of these giant patterns, which makes the statistics genuinely slippery. The signal could be a rare fluke that only looks meaningful, or it could be leftover contamination from dust and gas inside our own galaxy that nobody has fully scrubbed away. The argument over whether the axis is truly real stays very much alive. Yet 2 decades and 2 satellites later, nobody has managed to make it disappear. The mystery refuses to stop there. While cosmologists argued over which way the universe was looking, they slammed into a second wall trying to answer a far simpler question about how fast the whole thing is expanding. We have 2 independent ways to measure that rate, both of them excellent, and they flatly disagree. Read the expansion straight out of the cosmic microwave background with Planck using the early universe, and the number lands around 67 kilometers per second per megaparsec. Climb the cosmic distance ladder instead, the way Nobel laureate Adam Rees and his SH0ES team do with pulsating Cepheid stars and exploding supernovae, and the number climbs to about 73. That leaves a 9% gap between 2 rulers that ought to hand back the identical answer. For a while, you could pin the whole thing on a measurement slip, but that door has closed. The disagreement has hardened to roughly 5 sigma, which is physics speak for an accident that simply does not happen by chance. When JWST rechecked Rees's Cepheid stars to see whether crowded, blurry images were faking the result, the number held firm. 2 flawless measurements, 1 universe, and 2 different expansion rates, as though the cosmos cannot agree with itself about how quickly it is flying apart. That standoff points to some ingredient in our recipe, quite likely dark energy itself, behaving in a way the equations never predicted. Then June 2026 arrived. At the 248th meeting of the American Astronomical Society, a team led by Kyle Finner at Caltech's IPAC unveiled a galaxy cluster called XLSSC 122. We see it as it looked 10.4 billion years ago, during an era astronomers call cosmic noon, back when the universe was only about 3 billion years old and still practically a toddler. At that age, the standard model insists the biggest structures should still look loose, messy, and half-built, and XLSSC 122 does the exact opposite. It weighs in at something like 300 trillion suns, and its dark matter core packs together so tightly that it bends the light of galaxies behind it into visible arcs, making it the most distant cosmic lens of its kind we have ever found. When the team measured that core, it came out roughly 3.2 sigma denser than any Lambda CDM simulation says is even possible for its age. In plain terms, the universe finished building a mature, monstrous structure billions of years before our theory ever allowed the time for it. So look at what has piled up here. The axis of evil throws our place into question. The Hubble tension throws our physics into question, and XLSSC 122 throws our timeline into question. Three separate cracks, sitting in three separate corners of the standard model, all of them widening at the same moment. Here is the thing about cracks. One of them reads as a curiosity, two of them read as a coincidence, but three of them, spread across the direction of the universe, the speed of the universe, and the age of the universe, stop looking like unrelated puzzles and start looking like a single failure in the thing underneath all three. We have stood in this exact spot before. Back in 1900, Lord Kelvin surveyed physics and declared it basically finished, give or take two small dark clouds still hanging on the horizon. Those two clouds turned out to be relativity and quantum mechanics, and they did not get tidied away. They rewrote reality from the ground up. Nobody yet knows whether the axis of evil is a ghost hiding in the data or a genuine message written into the light. Nobody yet knows whether the universe's argument over its own speed marks a mistake or a doorway. What we do know is that the standard model of cosmology, the most successful description of everything we have ever managed to write, is groaning under three anomalies it was never built to carry. The most thrilling possibility in all of science is not that our theory turns out to be right. It is that our theory is about to become somebody's next great correction. The clouds are gathering over cosmology again, and the only question left standing is what waits inside them.